is K8BYP with a video on the facts and myths about SWR and SWR meters. This topic has more myth and obfuscation maybe than antennas, for as common as this is. Firstly, what is SWR? Well, the full term is usually VSWR, which implies voltage standing wave ratio. Firstly, there's no such thing as a wave. You look at a point in space, you see no wave, you see a changing voltage or current or field strength per time. If you stand on the beach at the ocean and look straight out to sea and look at a point, you'll see the wave rising and falling. Wave is an artificial construct that we see if we wade out in the surf and then turn and look parallel to the beach. We can see these crests and troughs, but at any given point of measurement, there is no wave. Waves do not stand. Waves imply motion. This is a problem we run into when we get away from the real concept, which is wave time. But we're not so accustomed to thinking about time as an inverse of frequency, because frequency is an easier concept to grasp. But forget about frequency and waves, think about time. Energy takes time to go down a transmission line, and that's a hard concept to get in circuits, because the connections are generally very short. What's meant by standing wave, especially from the old days, early on when there were no such so-called meters, is it on a line with energy flowing along it that's out of tune, mismatched. As we go further out the line in distance, that way, at some point along the line, we're not showing the other conductor here, but a voltage between here, this line, and some other conductor or some other point will be a maximum at this point, and depending on the wave time or frequency, sometime later will be at a minimum. And the difference in voltages is the voltage ratio. Take out the SW, V, SWR, that's the voltage ratio. That ratio translates eventually into SWR, which is kind of an artificial construct. When the line is correctly tuned, the voltage and or current are the same everywhere. When it's out of tune, the degree of out of tune is indicated by the height of this imaginary wave. In the old days, they made a loop of wire with a light bulb in it and moved it along this line until the bulb was the brightest and then the dimmest. And that demonstrated this VSWR, because the wave appears to stand because the maxima and minima are at fixed locations for a given frequency. In the later early days, such as the old Johnson, the round coupler and the meter head that sit on the desk, they used resistive dividers, which literally did measure voltage. In our real expert textbook, Lines, Waves, and Antennas, they do not say VSWR. Device to measure magnitude of reflection coefficient, from which we get this construct of VSWR or SWR. But measured across this two-conductor transmission line, we're measuring voltage drops across the resistors. The old Johnson micromatch did this. In modern times, we have this thing called a SWR and power meter, and that's two lies. That's like the joke about meals ready to eat, 3 lies the government told us. It's not a meal, it's not ready, and it's not edible. Well, that is not measuring SWR, and it's not measuring power. Doesn't make a bit of difference whether it says SWR on the meter legend or not. I could write on that meter legend pounds of dried fish, and that doesn't mean this is measuring dried fish. In modern times, we have what are known as, get the flashlight working. Sometimes things work better if you beat on them. Buried down inside this shielded housing is what's called a strip line. If you see, there are 3 copper traces on this printed wiring board. The lower one to the far right and left are soldered to the shield, implying that's ground. And up here, below the trimmer capacitor, and going over to the left and right, going up to a solder joint, that's the center conductor. That's where we say the current is flowing. That goes over to a gap with a piece of wire inside the yellow fiberglass braid. And around that are 2 toroid coils. Up to the right and the left, tilted out, are 2 germanium diodes, I think. Notice the red bands are up on both. Those are diodes with the anodes, with the cathodes up. Notice the 2 coils are wound in opposite directions. The wire comes off the one on the left and goes to the right, and the wire comes off the coil from on the right and goes off to the left. That means the coils are counterwound to each other. That's a strip line coupler. It's inductive and it's indicating current, not power. So what this is an RF ammeter, but it is calibrated in units of forward and reflected power. The forward and reflected detect the wave travel direction by those toroidal coils being wound opposite directions. If we recall our basic electrical principles, the different directions of current flow induce different directions of magnetic field travel. So one coil wound one direction detects forward and the other reverse. Then that's rectified by the diode, dropped through some resistors for impedance matching or resistive matching, and trimmed to RF with the trimmers, and ends up driving the meter. Recall Ohm's law. It is not possible to know power just by knowing current. We must know either voltage or resistance. There's nothing in here that measures voltage. So how can it be calibrated in units of power? It is because those are 50 ohm ports, and always 50 ohm ports. And the critical thing to understand with this BS nonsense about tuners is that when a system isn't 50 ohms, you can't believe what that reading is, because this thing deduces power by taking the current and figuring it with the 50 ohm system impedance or system resistance, and inferring power from that. And that's reasonably accurate as long as the system's 50 ohms. If it isn't, if there's reflected power, then the readings lose meaning. We can't deduce directly from this what the actual power is. But for this out of tune indication, what we're looking for is not the exact amount, but we're looking for the proportion. The SWR ratio, we're looking for a ratio. Some energy forward, some energy back. If this is placed at a point with a fake antenna tuner in the ham shack, and that's tuned to a low impedance, we might think the power level, the power indication would be different than if it were tuned at a point that's a higher impedance, but not 50 ohms. And that is what happens. So if we connect this up and we get a reading transmitting with 100 watts and it reads 150, something is grossly out of tune, because that is not a 50 ohm system. And that's a simple way to detect the fact that a tuner in a ham shack is not tuning the antenna. The only way that can be done is to modify the antenna, because the antenna tuning depends on its mechanical dimensions. And a fake tuner in a ham shack cannot affect that. It's also next to impossible to know if an antenna is 1-to-1 or not using one of these in a ham shack, because this is not at the feed point. And due to transmission line losses, which are greatly increased when the system's out of tune, some of the reflected power will be lost. So it's difficult to know if this is reading no reflected energy because the antenna is exactly tuned, or it's out of tune, but essentially all the power is being eaten up in transmission line losses coming back. So about the only way to know that is to get to tuning in the center of the band and tune either way and see across what frequency range it appears to be zero. And the correct tuning might be in the center of that range. But the only real way to do it is to put something like this at the feed point, which is why I like these low antennas. I have a dipole at 17 feet and one at 6 feet, and I can literally walk out and put a meter on the dipole if it's 6 feet, the 80-meter dipole. Just walk right out and touch the feed point. The ideal thing to do with this is to take that chassis off back here and literally put that at the feed point and run shielded cable back to carry these three conductors, the ground and the forward and reflected lines back down the feed line. And that would allow actually making the measurement right at the feed point. Another consideration if we're falling for the myth that there's a tuner in the ham shack is the old CB operator's trick of putting an extra piece of line, an extra piece of coax in the system to, as they foolishly think, to tune the system. It doesn't tune it. If this is reading current and this is moved to a point on the line where the current is a minimum, we will be fooled by this current indicating meter to think that it's actually measuring a 1-to-1 SWR when it isn't. It's been moved to a current minima, and it doesn't know any different. It just indicates that it reads a low current. So conversely, the thing to do if this is in the ham shack and it looks like it's a flat match, throw on another 10 or 20 foot of feed line and see if that indication changes. And if it doesn't, the antenna is out of tune.